This is the worksheet that goes with the graphing a logarithm worksheet. I just wanted to make sure that I could go over some of these problems with you, even though I'm not there with you. Number one, the answer is choice D. I know that you're not seeing the entire logarithmic curve, but if you were to continue drawing it, it would go down into quadrant 4. We know quadrants 1 and 4 are going to be a logarithmic curve. For number 2, what I would do is I would just guess and check using the log button on your calculator. If you put log of pi in your calculator, it doesn't come up undefined. If you put log of 1 over 10, it doesn't come up undefined. If, however, you go to choice D and you put in log of 0, there's your error. So it's undefined at 0. Same thing with number 3. If you put ln of 1 in your calculator, it comes up with a value. If you put ln of 0 in your calculator, it comes up as an error. So it's choice B. One of the things that I stressed to you last week when we solved equations is that the base and the number, neither one of them can be negative. Okay, they can also not be equal to 0. The only thing that this x minus 4 can be is positive. So do x minus 4 is greater than 0 and add 4 to both sides. It's x is greater than 4, which leads you to all defined values, which means x is less than or equal to 4 is going to be undefined. Okay, so as I'm reading that right now, I'm seeing how tricky that one is. It's got to be where it's undefined. This is where it's defined. This number has to be positive. Okay, so now that I know about that, if I take a look at number 5, this one is asking for where it is defined. So this has to be positive. X minus 8 is greater than 0. This one's tricky. You have to be careful. I would add x to both sides, so I get 8 is greater than x. And if you flip that around in a way that we're used to reading it, it's x is less than 8, and it's going to be choice A. Okay. If you want to check it out for yourself, you could pick a number that's less than 8, plug it in for x, use the log base trick on your calculator, see if it works. Pick 8 itself, plug it into the log base trick on the calculator, see if it works, and then pick something larger than 8. That should be able to help you narrow it down. Number 6, the equation is not set equal to y, so we're going to want to take this and put it in exponential form. The base is 2. A logarithm is an exponent. That's the exponent. That's your exponential function. Okay, that was the first thing that we graphed on the other worksheet. And the domain for that graph, I'm just going to give you a quick sketch, is all reals. Okay. Okay, I'm going to move on. If you want to come back and look at this video, I'm going to post it on my website so that you can see it again, just in case it's moving a little too fast. Number 7, what is the domain of this function? Now, once again, this has to be a positive number. So x minus 2 has to be greater than 0. You're going to add 2 to both sides. It's everything greater than 2, so it's going to be choice C. Okay. Number 8, you could do in the calculator. Just go into your y equals. Okay, make sure everything's cleared out. You need to do log base 3 of x. So math, hit the up arrow twice. Log base 3 of x. And then it's y equals 2, so that's going to be your second equation. And when you hit graph, you're looking for where they intersect. Okay, it might be hard to see from the graph, but if you go to the table, you're looking for where the y columns are both equal to 2, and there you go. Y is equal to 2 in both columns. That's when x is equal to 9. Okay, hopefully that's a choice, and it is. Okay, so I'm just using old school ideas about systems of equations in the calculator there to answer that question. But you do have to know how to put this log base 3 of x in there. Number 9, well, we know it's a logarithm because it's quadrants 1 and 4. So this and this are out. What I would do personally is I would try to find a point on the graph that makes sense. It looks like when x is equal to 2, y is equal to 4. Sorry, other way around. I can't edit this. Sorry, guys. When x is equal to 4, y is equal to 2. As long as you can find an equation where that works, okay, it's actually going to work for this scenario right here. It's going to be a base of 2, so it's choice A. Number 10, that is a logarithmic curve. It's obviously been reflected in something. It's still quadrants 1 and 4, so I know it's not exponential. And because it's a reflection, folks, there needs to be a negative. It's been reflected in the x-axis, which means y is being negated, so that's why it's choice B. Okay, I'm going to flip this over. I know I'm moving fast, but once again, it's on my website. All you have to do is go to Algebra 2, find the Logarithms tab, and it'll be there. Both videos, both the graphing and this video. Okay, turn it over to the back. We're not going to do everything on this worksheet also. Number 11, which is an expression for the equation in figure B? Well, that's the inverse of y equals 2 to the x, so it's going to be y equals log base 2 of x. So it's going to be choice A. Okay, this is a quadrant 1 and 4, so it's not an exponential. Okay. Number 12. Oh, we get to put that into our calculator again. Okay, it's ln of x for the first equation. And e to the x, don't forget e is above the division symbol, so second e, raise it to the x. Look at the graphs. Okay, that's ln of x. And here's e to the x. They're reflections of one another over the line y equals x. They're inverses. Okay, hopefully you recognize that maybe without even looking at the graphs. Which of the following is the inverse relation of y equals log 5x? Well, it's x equals log 5y. And that's not an equation that's here. So what we're going to do is we're going to assume there's a base of 10 there. I know this is written in the opposite order. Some of you like rewriting it. But it's a base of 10, it's raised to the x, and it's equal to 5y. All of your choices, y is by itself, so we're going to divide by 5. Okay, just so you know, I normally do not get to number 13 in my classes. And it's a little bit of a challenging problem, but the answer is choice D. Okay. Number 14, the inverse of a logarithmic function in the form y equals log b of x. Which equation represents the original function? Well, inverses are where you switch x and y. Sorry, I messed that x up. Can't edit it. This is the only thing that stinks about making videos on the Ladybug. And if you look, this is not the format that any of your choices are in. It's a base b. Oh, that should be a y too. B to the x equals y. And it's going to be choice B. Sorry, I didn't like the way my x looked, and it messed up my y. That's all I could think about. And then if you go back to your calculator, we had already graphed ln of x. It's this curve right here. It gets really close to the y-axis without touching it, so the line x equals 0 is an asymptote, so it's going to be choice D. Okay, and like I said, I don't think I've ever gotten to 12, 13, 14, and 15 with any of my classes in the past. Not that they're, particularly difficult, but I did put them at the end because they were a little bit more challenging. If you can do them, that's awesome. If you have questions about them, I'll answer them tomorrow. I'm not going to worry about the graph right here. Hopefully my little quick discussion of each problem helped. Hopefully you got a lot of them right on your own. And I hope you enjoyed this worksheet.